Hello friends, welcome to Independent Learning. My name is Raj Shah, and in this video we are starting with a new chapter which is trigonometry. Okay, so we are going to learn what is trigonometry and what are its uses. Okay, and why do we use trigonometry? Because I have seen that many students often feel that why are we studying trigonometry, what are its uses. Okay, many higher standard students, they find it difficult also. But in this video, we are going to start with the most basic thing in trigonometry, and gradually you'll understand the basics of it. Okay, and it will become very easy for you. Okay, so I hope you watch it till the end so that you understand each and every aspect or a small point in trigonometry. So this chapter becomes very easy for you. Okay, so let us start. First of all, we'll start with the word. What is the meaning of the word trigonometry? So I've written it in short forms. Okay, tri means three. Okay, gono means side. Okay, and metry means measurement. This is side. Okay, so three-sided measurement. That means if it is three-sided, you know that it is a triangle. Yes or no? So if there is a triangle which is three-sided figure, so measurement based on three-sided figure. Okay, I hope you have understood. Let me give you an example. Let's say if you want to find, okay, let's say there is a building here, okay, and you are standing at this point. Okay, so you are standing at this point and someone asks you, okay, to find the height of the building. Will you be able to say? No, right? Of course not, because you cannot look and you can calculate the height of the building. You cannot say half the size of the building also. Okay, so okay, that was a joke. So to find the height of the building, how can we use the measuring tape also to find from the foot till the top? Can we use the measuring tape? Have we ever implemented such a long tape? No, right? So we cannot use a measuring tape also to measure the height of the building. Yes or no? So how do we do it? So it's done using trigonometry. Okay. So I hope you are understanding this, what I'm saying. What are the uses of trigonometry we are learning? Okay. So trigonometry, it has a vast application in terms in real life. Okay. Like for example, I'll give you one more example. Okay. If let's say there is this moon here, okay, and there is earth at this position, okay, and let's say the sun is there here. Okay, did you understand? The position of moon is here and earth is here, and this is the sun. Now if you how do you think the distance between sun and earth is calculated? How would the scientists might have calculated? Do you have any idea? No. Let me tell you that the distance between sun and earth, it can be calculated. Okay, it can be calculated using trigonometry. Of course you cannot go till near sun, because you know it's very hot, so you cannot travel or you can reach towards the sun. But yes, of course you can travel to moon, correct? So we form a triangle like this. Okay, now this is kept 90 degree, okay, the triangle. And to find the distance here, we can find the distance between this and this. Let's say it's a kilometers, some kilometers. So to find this, the distance between sun and the earth, it can be found using trigonometry again. So I'll tell you how to find this towards the end of the chapter. Okay, I mean towards the end of the video, to how to find the distance, okay, the height of the building, or you can say the distance between the sun and the earth. How do you find it? Yes or no? Or you can say the distance between moon and the sun. How can you find it? Okay, or distance between any two planets, how can it be found? Yes or no? Because they are vast, they are spread in the solar system. Yes or no? So in order to find the distances, the information about all those things is done, it is found using trigonometry. Okay, so I hope you have understood what is the importance of trigonometry, and why is it useful, and how is it useful in day-to-day life in order to calculate the height of the building, or you can say anything else to find the distance from one point to another point. Okay, so to find that without measuring, of course, so that is done using trigonometry. Okay, so let us get started with the basics, okay, of what trigonometry is. Let us understand first. Now, you know what is hypotenuse theorem? Yes or no? Or sorry, Pythagoras theorem. You know that. Okay. So Pythagoras theorem says that hypotenuse square, you might have learned this in your lower standards also, so we are just revising that. Okay, so hypotenuse square is equal to one side square plus other side square. Yes or no? That means if you want to apply Pythagoras theorem, let's say for this is A, B, C, any triangle with angle B as 90 degree. Okay, so I hope you are understanding this. So the hypotenuse is the side. Okay, let's write it. Hypotenuse hypotenuse is the, okay, this is what this is. There are three sides. Okay, hypotenuse is one side, this is one side, and this is another side. So there are three sides involved in Pythagoras, meaning it takes into the account of a triangle itself, no other figure for Pythagoras theorem. Okay, let's understand this and you'll understand this better. Let's understand what is hypotenuse. So hypotenuse is the side of a triangle. Okay, so it is a side of a triangle itself, but what is its characteristic? That it is opposite side of 90 degree angle. Meaning, now what do you understand by opposite side of 90 degree? So if you see, this represents 90 degree. Now the side opposite to 90 degree is this side. Yes or no? So this is angle B. Okay, angle B is 90 degree. Yes or no? So the side, okay, this is the angle. Angle B is 90 degree. So angle opposite to this angle, which side is there? This side, correct? So you just look at the side opposite. So this side AC is the hypotenuse. So we'll say this has AC square in terms of this triangle. So the hypotenuse here in this triangle is AC. Okay, so I hope you have understood. So when do we use this Pythagoras theorem? When one of the angle of a triangle is 90 degree. Okay, so when do we use this? When one of the angle is 90 degree. Okay, so I hope you have understood this. Now one side, so this AC is been taken, so we can take one side as AB or BC, so it's up to you. So I'll take AC square and then plus BC square. So if AC is the first side, sorry, not AC, AB. So if AB is the first side, then BC will be the other side. Or you can take BC as the first side, then AB as the other side. Doesn't matter much. Okay, so this is what Pythagoras theorem is in terms of this triangle. Okay, if you want, we can write for this also, for this triangle also, SME. Okay, so for this triangle SME, we can say SE is the hypotenuse. Why? Because this is 90 degree and this is 90 degree. The side opposite to 90 degree is SE. So SE is the hypotenuse and there are two sides which is SM and ME. So just square and add. So SM square plus ME square. Okay. So I hope you have understood what is Pythagoras theorem. Now let us understand if two triangles are similar. Now if I say ABC is similar to SME, for example, I'll write it here. If triangle ABC is similar to triangle SME. Okay, so if this is happening, okay, if this is similar, means we have done this in the chapter triangles also. What is similarity of triangles? So if you are confused with what this similarity is, it's better if you check that video first of the chapter triangle. So let's see what the characteristic of similarity is. So if the two triangles are similar, you remember that the sides are proportional, meaning if I take AC, so AC upon SE. Why am I taking AC upon SE? Because AC is the hypotenuse here in this triangle, and in this triangle is SE is the hypotenuse. So we are supposed to take the same sides of the triangle. Okay, then this is equal to, okay, this is equal to AB upon SM, AB upon SM. Okay, I cannot say AB upon ME because this will not look similar. AB and SM, they look similar. Standing lines, yes or no? So same way, AB upon SM, then BC upon ME equal to BC upon ME. So this is what sides are proportional. Now what do you mean by proportional? That when you divide two sides of triangles, okay, sorry, one side of both the triangles, then you get the ratio same. Okay, so I hope you have understood this. This we have done in previous chapters itself. This was just the revision. Okay, to continue with the chapter, let's see the other things now. Okay, so we'll see what is terms related to right angle triangles. Okay, so first of all, right angle triangle means right angle. So there is this triangle where one of the angle is a right angle, meaning one of the angle is 90 degree. Okay, I can make a triangle like this also, where this is 90 degree. Okay, so we are naming this ABC and this is PQR. Okay, so we have just named this. Now we are supposed to find terms related to right angled triangle. Okay, so what are those terms? Now for example, okay, if I talk about angle C, okay, now angle C is here, this is angle C, correct? Now what is the side which is opposite to angle C? As we discussed there in hypotenuse, we saw that if this angle is 90 degrees, so angle B is 90, then this is the hypotenuse, meaning the side opposite to 90 degree, correct? So this is the angle 90 degree. So this is the opposite side of this angle. Opposite means they are apart, right? Opposite to each other. Yes or no? Same way for this angle, AB is the opposite side. Yes or no? So we can write angle C. So for angle C, AB is the opposite side. Yes or no? Now, if I talk about adjacent, what do you mean by adjacent? Adjacent means just nearby. Yes or no? Can I take for this is C, right? Point C. So for point C itself, which one is the adjacent side? If you think about it. Now, AC is the hypotenuse, we know that, correct? So for point C, there are two sides which are adjacent. Adjacent means close by. Are you getting? Opposite means far away, which is this AB. So AB is the opposite side, we have understood. Now, what are we finding? The adjacent side. Adjacent means close to. So for point C, which side is close to point C? It is BC, which is one side, and AC is another side. Yes or no? Now, can I say AC is the AC is the adjacent side? No. Why? Because AC is already the R hypotenuse of this triangle. So we'll take adjacent side as BC. Right? Therefore, for angle C itself, we can say that, okay, we can say BC is the adjacent side. Okay, so I hope you have understood this. Let's see for angle A. Okay, so let's see how to find for angle A. For angle A, which one is the opposite side and which one is the adjacent side? So this is angle A. The side opposite to angle A is this. You can see the adjacent sides are this and this, which is AB and AC. So let's see. So adjacent sides are this. Now first of all, opposite side is BC. Yes or no? Therefore, BC is the opposite side. Okay. And which one is the adjacent side? Can we say AC or AB? Which one? So it will be AB. Why? Because AC is already the hypotenuse. Yes or no? Therefore, we'll say AB is the adjacent side. So in this, AB is the adjacent side. Okay. So I hope you have understood this for this triangle. Let's see for this. If I talk about angle P, okay, angle P, which one is the opposite side and which one is adjacent? Opposite, adjacent side. Okay, so opposite side and adjacent side. Which one is it? Angle P is this. Opposite will be QR, because this is the angle, and opposite will be just opposite. So QR. So QR is the opposite side for angle P. Okay, and for adjacent side of angle P, which one is it? See, if you see, this is hypotenuse. Let's write here also hypotenuse. So can I say PR is the adjacent side? No, because it's hypotenuse. So which other side is remaining? PQ. Therefore, PQ is the adjacent side for angle P. I hope you have understood what is opposite side and adjacent side. Okay, adjacent means just close to P, which is PQ and PR. But you cannot take PR because it's hypotenuse. That's why you take PQ as your adjacent side. Okay, now let's find for R. For angle R, okay, now you can find this out. What is opposite and adjacent side? So I hope you'll be able to find. Opposite side for R is PQ, and adjacent side of R is PR and RQ. But PR is hypotenuse, that's why you take RQ, or QR you can name. Okay, so I hope you have understood this. Now let's see trigonometric ratios. What are they now? We'll discuss. Okay, so trigonometric ratios we'll see now. So let's see some trigonometric ratios. Now you know ratios, it means something upon something. Like if you say 2 upon 3, so this is a ratio which is 2 is to 3, correct? So we are going to learn the sides, okay? The sides will be divided by the other side. So one of the side will be divided by the other side, and we'll see the ratios of them. Let's start and you'll understand it better. Okay? So here the first ratio, okay, which we are going to learn is sine, okay? Sine ratio. Now sine ratio is equal to, so what is a sine ratio? So this is, sorry, opposite side upon hypotenuse. So what is the sine ratio? It says that opposite side upon hypotenuse. So the ratio of opposite side and hypotenuse is called sine. So if you think of example, let's take, okay, let's take for example angle B. Where is it? Angle B. Oh, sorry. We'll take for angle C. Okay, angle C in this triangle. So I'll say angle C in triangle ABC, and here in triangle PQR. Okay, so for angle C, what is sine? How do you find sine? That will be, now let's say for angle C, this is angle C. What is the opposite side of angle C? Which one is it? AB? Yes or no? Okay, first of all, we can say opposite side of, I'll have to erase this, angle C, okay? Opposite side of angle C upon hypotenuse. Opposite side of angle C. So for angle C, we are considering angle C, right? For triangle ABC. So we'll say sine C. Okay. So for sine C, okay. So this ratios, okay, sine, then we'll be learning what is cosine, then tangent means tan, okay. So we'll be learning all those ratios, and those ratios are dependent on a particular angle of a triangle. Like for example, I can find sine C. So for angle C, what is the sine ratio? Okay. So what is it's given by, you read this as sine C, and you don't write SINE. E is not written. You just write SIN. So this is read as sine C. Okay. So this says that for angle C, what is the sine ratio? That will be opposite side of angle C upon hypotenuse. So that will be given by, okay, I'll write it here, by angle C is this. Opposite to angle C is what? Which side is opposite to angle C? It is AB. So I'll say AB, okay, AB upon hypotenuse is what? AC. So we'll say AC. Okay. So I hope you have understood how to find sine C. So sine of any angle can be found like this. Opposite side of angle C upon hypotenuse. We don't write hypotenuse of angle C because hypotenuse in any triangle remains the same. That is, what is the hypotenuse? The side opposite to 90 degree. That is always the hypotenuse. So you cannot change what is hypotenuse, okay? Therefore, we just write hypotenuse and not hypotenuse of angle C. Okay? So I hope you are understanding this. Now, if you want to find sine This is C, right? What is how to find sine of A? Now sine A can be found using opposite side of angle A upon hypotenuse. Yes or no? So sine A is opposite side of A is what? BC. Okay. So this is equal to BC upon hypotenuse is AC. Okay. So here if you see AC, ACC, the hypotenuse remains the same. That's why we don't write hypotenuse for angle C or angle A. Correct? So this is what it is. How to find sine ratio. I hope you have understood what is sine ratio. It is simply a ratio which is to divide opposite side with the hypotenuse. So that is itself called sine. Are you getting? So opposite side upon hypotenuse is called sine. So sine of any angle, if you want to find, it is found by opposite side of that angle upon hypotenuse. Okay. So I hope you have understood how to find sine. If you want to find for this triangle, P. Okay. So if you want to find sine P, how do you find it? You know, opposite side of angle P upon hypotenuse. Now in this, hypotenuse is PR, therefore, so I'm writing this directly, PR, and above its opposite side of angle P. So opposite side of angle P is QR. So that will be QR upon PR. Okay, so this is what it is. Now if you want to find sine R, okay, so sine R can be found by, again, opposite side of angle R. So opposite side of angle R is PQ. Yes or no? So we had written this somewhere here, right? So opposite side of angle R is PQ. So PQ upon hypotenuse will remain the same, which is PR itself. So PR comes here. Okay. So I hope you have understood how to find sine of any angle, okay, in any triangle. Okay. So let's find the other ratios, which is cosine and tan also. Let us see. Now, what is cosine? Okay. Let's so for these two same triangles, okay, let's write for cosine. Okay, so cosine ratio is adjacent side upon hypotenuse. Okay, so cosine ratio is, you just take the adjacent side and divide it with the hypotenuse. Okay, I hope this is clear to you. You are understanding. There is no big thing like anything like apart from the triangle, because it just has to find opposite side of a particular triangle or adjacent side of a particular triangle and upon the hypotenuse. Okay, that's why we found how to that's why we saw how to find the adjacent side of an angle or opposite side of an angle. Okay, so let's use this over here. Now cosine ratio. So cosine ratio, it's written as cos. It's written in short, which is cos, COS. So if I want to find cosine of A, so that will be given by, so it will be again cosine of any angle. Okay, just like sine of any angle, it is given as cos A is, so if you see cos A, adjacent side, I'll write adjacent side of angle A upon hypotenuse. Again, I'm not writing hypotenuse of angle A because hypotenuse in a triangle remains the same. Okay, so I hope you are understanding this. Now, adjacent side of angle A is, if you see, opposite side is BC, so we won't take this. AC is the hypotenuse, we know that. Therefore, adjacent side of A will be AB. Okay, so adjacent AB upon hypotenuse is AC. Therefore, AB upon AC. Okay, so I hope you are understanding this. Now, let's find for cosine C. Let's directly find this without wasting time. So cosine C is, adjacent side of C is what? It can be AC or BC. But can I take AC? No, because it's hypotenuse, you know that. Therefore BC. So it will be BC upon hypotenuse, which is AC. Okay. Now find cosine of P and cosine of R. So I want you to find this out. Okay. Now we'll see what is tan, how to find tangent ratio. So the third one, which is okay, TANGENT, tangent ratio. So that is given by opposite side upon adjacent side. So you just take opposite side of any triangle, sorry, of any angle, and adjacent side of any angle, and you divide them. That will give you tangent ratio. So if you see, this is nothing but, so these are the ratios. You just take the opposite side or the adjacent side and the hypotenuse, okay, and you divide them. So if you divide opposite side with the hypotenuse, you will get sine. So that ratio, opposite upon hypotenuse, is called sine. Okay. And what is cos or cosine? It is just adjacent upon hypotenuse, nothing much. When you divide adjacent side with the hypotenuse, you get cos. When you divide opposite side with the adjacent side, you get tangent. Okay, so let's see what is tangent. Therefore, or tan. Okay, you write tangent in short, which is tan. So let's find for tan A. Now you already know for A, angle A, which one is the opposite side? BC. Yes or no? So I can say BC. Okay, opposite side BC upon adjacent side. So adjacent cannot be AC, it will be AB because AC is the hypotenuse. So AB. Yes or no? Therefore I get tan A as BC upon AB. Okay, so I hope you are understanding this. Now tan, let's find for tan C. So tan C is opposite upon adjacent. So opposite is AB upon BC. AB upon BC. Correct? So I hope you have understood this. Now find for tan P and R. Now you know how to find tan P. P is this, opposite side is QR. So QR upon adjacent side is PQ. So QR upon PQ will be tan P. Same for tan R also you can find. Okay. So I hope you have understood this. What is sine ratio, cosine ratio and tangent ratio. Okay. Now we'll see some questions. Okay. We'll see some questions based on them. Okay. So let's see. Now before starting with the questions itself, if you see, if I take Okay, if this is if this is 90 degree, okay, let's say this is P, Q and R. If this angle is 90 degree, you know that this is hypotenuse, correct? Now let's say that angle Q is theta. This is called theta. Okay, so we represent this angle with theta. So we say if you want to find sine theta, okay, whereas this theta is actually angle Q itself, okay, so we can represent this angle Q with theta. Okay, we can represent this R with some other letter also, okay, that is phi, like this phi. Okay, any other letter can be used. So we are representing this angle Q with theta. Now if you want to find sine theta, how will you find it? You know that sine theta is opposite side upon hypotenuse. So what is opposite to Q? Opposite to Q is PR. So PR upon hypotenuse is QR. So this is sine theta. Then what is cos theta? You know that it's adjacent side upon hypotenuse. Therefore adjacent side is of theta is what? PQ, correct? So PQ upon hypotenuse will remain QR itself, which is this. So QR, correct? Now to find tan theta, okay? Now to find tan theta, tan is what? Opposite side upon adjacent. So this will be theta here. Opposite is PR, we know that, upon adjacent is PQ. So PR opposite side upon adjacent, which is PQ. Okay, so I hope you have understood this now. But if you think, see, without knowing this formula also, we can find for theta, tan theta. You know how? Let us see here. If I divide sine theta with cos theta, see, sine theta is this, cos theta is this, PQ upon QR. So let's divide that, divide this with this, that is dividing this ratio with this ratio. Okay, let's see that. Okay, PR upon QR divided by PQ upon QR. PQ upon QR, correct? So this divided by this, so this will be given as PR upon QR into, so division means ulta multiplication, so QR upon PQ, yes or no? So QR and QR will go, you'll get PR upon PQ, so that is P R upon PQ, that is this, see, PR upon PQ, so that is tan theta. So tan theta can also be called as the ratio of sine theta and cos theta, means tan theta is sine theta upon cos theta. Okay, so I hope this is clear to you. Now people often get confused, what is tan theta, you keep on saying tan theta is sine theta upon cos theta and all that thing, right? You keep on repeating all those formulas to remember it. But if you see properly, okay, if you divide this sine, after finding sine and after finding cos, just divide sine and cos and see what you get. You get PR upon PQ, which is tan theta itself we have found here. So that is same, therefore tan theta is sine theta upon cos theta. Okay. So I hope you have understood how to find this. Now we'll take some questions based on this, okay, and we'll end the topic here. So let's see some questions. So let's look at a couple of questions, okay. Let's try to solve it. Now this all is based on what we discussed, okay, opposite side, adjacent side. We just need to remember what is sine, what is cos and what is tan. Okay, so what is sine? you know that sine is what? Opposite side upon hypotenuse. So sine of x will be opposite side. Okay, this is x. Opposite side of x, x is this angle. So opposite side of angle x upon hypotenuse. Now if you see, this is 90 degree. Okay, before starting with this questions, okay, before starting, I want to say that whenever you try to find these ratios, you always have to see whether a triangle is a right angled triangle or not. It always has to be a right angled triangle. Why? Because if this is not 90 degree, this will not be hypotenuse. Are you getting what I'm saying? So there has to be a 90 degree. So that means whenever you try to find trigonometric ratios, the triangle which is given to you should be a right angled triangle. Meaning at least one angle should be 90 degree. Okay. So I hope you have understood this. Let's see the question now. So there is 90 degree here. That means the 90 degree का opposite side is xz, which is with uska length is c. So c is the hypotenuse. So we can write that here. This is the hypotenuse. Correct. Now how to find sine z? Sorry, sine x. X is what? Opposite side. So opposite side is yz of x. Yes or no? So this is yz. Therefore we can say yz is a upon opposite upon hypotenuse, right? For sine. So hypotenuse is xz, which is c. So c. Now you can write this like this also. Opposite side of angle x upon hypotenuse. Okay, then opposite side of angle x is yz. So yz upon hypotenuse is xz. So this is xz. Now yz is what? A. So this will be A, and xz is C. So this can be written like this also. Okay. So this full can also be written or directly A upon C. So without wasting time, we'll directly try to find this A upon C. Now this measurements A, B and C, they are given to us. In this question, it is not given to us. So we'll directly write this as LM or MN and LM. Okay. Since it's given, we'll write it like this. Okay. So let's see. Tan Z. Now you know tan is what? Opposite upon adjacent. Okay. So opposite side of Z. This is Z. Opposite of Z is yx or xy, which is B. So B upon opposite is this and adjacent is A. So B upon A. Okay. So if you want, you can write it this way and then you can get this. That will be easier for you. But I already know it. So I can write this as B upon A. Same for this cos x. You can check that out. Cos x will be, you know, adjacent upon hypotenuse. So hypotenuse is C. Adjacent for x. X is B. Correct? B, which is xy, this side. And tan x. What is tan x here? X is this. Tan is opposite upon adjacent. So opposite is A upon adjacent is B. So this will be A upon B. Okay. So I hope you have understood this, how to find. Let's find for these now. Another question here. LMN. There is an angle which is 90 degree. So yes, we can find this out. So sine 50 here. Sine, you know, it's opposite. Okay. So opposite side of angle 50. Okay. So opposite side for 50 is MN upon hypotenuse is LN. So let's write this as hypotenuse LN. Okay. So I hope you will be able to find all these also. I'll try to find this also. Now Okay, cos 40 I'll show. This is 40 here. Now adjacent for 40 is what? Adjacent side, it's mn. Yes or no? Because opposite side of 40 is ln. Therefore mn is the adjacent side. Now you know cos is adjacent upon hypotenuse. So I would say adjacent is mn upon hypotenuse is ln. This is what it is. Okay. So I hope you have understood this. Try to find these two. Okay. Now I hope you have understood this topic. We end this topic here. Now in the next video we'll see some more details in this chapter. We'll go further in this chapter. Okay. So I hope you have understood this video, and if you have understood it, make sure that you share it with your friends. Okay. Thank you for watching.